So I'm here at Whitehouse Machine Tools today. I'm with Dan Hayes, and we're talking about the Brother series of machines and the fact that these BT30 machines that Whitehouse Machine Tools have been selling for some time are becoming extremely capable. And often companies are buying BT40s, Dan, which we'll talk about, when really they should be considering this technology because the savings are potentially great. Now, Dan, in your opinion, the BT40 versus the BT30, how sophisticated are these machines coming from Brother now that, you know, they're eroding into that BT40 market, and why?
Well, it's as technology develops, we're able to actually adapt to it and take advantage of those aspects. For instance, recordial milling, it's called different on different softwares, but we're able to actually achieve those feed rates quickly because we've got the acceleration, we're not traversing the mass. So we're not waiting around for the point A to point B, we're already there.
Now, we're going to touch on this particular episode, and there will be a few episodes that we dive into detail about some of the elements of the BT30 Brother machine. Here we're talking about reductions in cycle times and reducing downtime, two really key areas, aren't they? Can you maybe explain what they are and why they're important?
Yeah, so it's obviously, it's a main aspect. You're going to, obviously, you need to deliver the parts on time. So if you've got a big advantage of reducing the cycle time, then that's a big critical aspect. So we've got technology, for instance, simultaneous tool change, which will tool change. It will also position all the axes as well as your additional two axes all simultaneously, and eliminating that waste. And you'll see it's a topic across the whole Brother range. And
I guess this is about machine dynamics, which is a big part of what we're talking about now. These machines, when you watch them, they're incredibly quick. But that comes across in every area of the machine, doesn't it? From the tool changer to the acceleration, the deceleration. How important are those areas, and what are the real key ingredients to being able to reduce the cycle time significantly compared to a BT40?
Well, that's it. It's we're taking advantage. We can get up to 2.2 Gs on acceleration on our X, Y, and Z axis. We can go from 0 to 16 RPM instantly, essentially, which allows for faster tapping cycles and retracting. So all of these little advantages just lead to a big old time difference when comparing to a 40 taper spindle.
And how do you illustrate this to a user? People will be watching going, well, you know, I've got 4 or 5 VMCs, they're BT40s, I'm not sure, or how are you going to prove to me that my application is going to be faster using one of these machines than what I'm currently using?
Well, we find we're doing more and more exercises by doing a like-for-like comparison. We can somewhat reinvent the wheel, but it's better to take their programs out of their VMCs, put it into our Brothers, which are very, very configurable. Most controls are like-for-like, and we can then just show them their actual current manufacturing process, but with roughly an expected cycle time reduction of about 30%.
And is that what you would kind of say would be a standard saving on a standard application? Are you talking really gains that are that significant?
Yeah, so it can be higher than that normally, because depending if they're doing more drilling and tapping, then obviously there isn't a platform out there that will beat the Speedio range. But effectively, if you're doing tricordial milling and high performance milling, keeping up with the technology, what the CAM systems can provide, then you really will harness the advantages that Brother have to offer.
Because there are some people that might be watching this that would be thinking, these machines are drill tap machines, you know, they're just for aluminium, they're for long production runs. And I guess we're dispelling that myth that these machines are about flexibility, aren't they? They can handle all kinds of materials. Do they have the robustness within all the areas you talk about to be able to cater for job shops? Because that's really who we're aiming this topic at.
Well, yeah, a lot has changed. Back in the day, you used to take big old cuts, slow cuts, but now technology is developed, cutters are developed, people are taking lighter, faster cutters, and material removal rate is far superior with these new strategies. All we're doing is capitalising that with our accelerations, our speeds, and that is, I suppose, the most important aspect, is really driving with the technology.
And when I look at the machine, it's significantly smaller. Some of the moving parts would be lighter. So I guess you're moving, you know, a lot of less mass around, aren't you, in the machining process? Now that would be better for speed, but would you guys argue that would be better for the longevity of the machine as well? Are there other elements of savings?
Well, that's it, yeah. So you're traversing the mass, that can wear anything out. Obviously, with the reduction of that, you're going to get better repeatability over time. The lifetime of these machines, the reliability is really good.
And that would bring me on to reduction in downtime, because OEE is something that you talk about a lot, and so do other machine tool providers. The average VMC, probably people watching this might have one in their machine shop, and that spindle is in action less than maybe 40% of the time. That's what you want to eliminate, or you want to improve on, don't you? I mean, is that part of your reduction in downtime strategy?
Well, yeah, we want to improve on that. Obviously, you want to eliminate all aspects. So you want to get your work holding developed to allow you for quick operate and quick changeover. And then if you're investing into work holding to allow you to gain or to lose the setup times, why not have a capable product to allow you to then further eliminate the additional or wasted time? And then effectively, reduce the delivery times to the customer effectively.
Which is what everybody wants, don't they?
Yeah.
I mean, and it'd be crazy to think that someone's watching this that thinks, I don't want a machine that's faster, I don't want to reduce downtime, I don't want to reduce my cycle times. That would kind of be unheard of.
Yeah.
But from your opinion, you guys are very excited about the prospect of how you can expand your market with the new BT30 technology. How often are you facing those conversations where people go, do you know what, I don't need that, I don't believe that, or, you know, how do we convince them further, Dan?
Well, it's just the proof's there. We just need to have the customer consider the product. If we're able to get them and highlight the differences with proving out a BT40 program on a BT30, then that's done. We've done that many times before. It just clearly highlights where the advantages are. We just need that opportunity to come about more often.
There's one more point I'm going to make, and it might be on the lips of some of our viewers. A BT40 machine often might have a meter table, a meter x-axis. They'd be holding maybe one part on there, quite heavier, larger.
Yeah.
Can you accommodate parts that would be the equivalent in size to what you might get on a VMC 1000? And if so, if they were heavier, have you still got the same dynamics on the machine?
Yeah, so effectively, not everyone will utilise the whole bed space. We've got obviously a range, we've got a series range that goes 300, 500, 700 and also 1000, and we can accommodate different working envelopes. But if you have heavier billets on a smaller machine, we can then slow down the inertias and calculate the actual mass, so then you won't lose positional accuracies because it knows to slow down and to speed up differently depending on the weight.
Thank you very much, Dan. So if you're interested in reducing your cycle times, improving your productivity, then a BT30 machine from Whitehouse Machine Tools and Brother could be the answer for you. Thank you very much, Dan.
Cheers, thanks Paul.